Ladies and gentlemen, welcome back to what is basically episode 2 of 3D printing cool stuff. Before I can get into this, I'm going to send some images to myself. Oh, shit. I guess I have them right here. Anyways, the basic thing we're going to do today is we are going to make the platform. And I've decided to change things a little bit. So I'm going to make, instead of this being one big square platform with 3 small circles, right? I'm going to do a couple modular platforms that all lock together using some kind of small locking mechanism, and each one of these only has a single pillar on it. And what that's going to do for us is we can run straight across. So let's look at a side preview, so what that'll look like, right? We got 3 platforms. Right? We also have 3 pillars. And then we have our gears. So we start with a small gear, which directly drives a big gear. Which turns a small gear faster, which directly drives a big gear, which turns a small gear faster, which directly drives a big gear, which then in turn is going to drive... Actually, this big gear needs to be something else. What the hell? What is that tool? No. This needs to be a big 45 gear. What that's going to do for us is we can come out here and attach another structure out here, because really that gear will end out here. And I will connect that to a 45 gear here. Which is going to connect to another one with the opposite 45. Okay? And this is going to drive the crankshaft for the engine underneath. And I'm going to have... This is my final image idea for it anyways. I'm going to have a large... Okay. I'm going to have an engine case that is also going to be modular. So, that is our gear shaft. The gear shaft needs to sit inside of the lower part of the case. Also, just a side note, this case, also modular, splits down the middle. I'm going to have some tongue and groove connections to hold it in place on every face of it. So the only way it slides is in and out up. And then inside of here, each of these crankshafts is going to drive 4 pistons. So every turn of this top gear will result in like 10 or 20 pumps of each of these pistons, theoretically. And now this is where I do actually need to get these pictures, because I can't draw this again. these to myself. Compose to me, attach. God. These two images. Shit. Okay, here we go. So now, come over here. Gmail. To me. Right, so, this is where things get interesting. Okay, only this one's sent, but this is the important one. What I'm going to do is I'm going to have this crankshaft. Then I'm going to have this assembled so I can snap it over the crankshaft and it can rotate. And it has a second pivot point in the middle that's going to be held together with a solid bolt. So what that's going to do is, well, actually I can show you. It's going to basically work like this. So a system like this, in which I apply rotational force to this. This turns, which draws that in and out as it goes around in this circular motion. So, with that being said, let's start figuring out some dimensions. Perfect. Perfect. This is exactly what I need. So, aha. Okay, I'm learning. So, I'm just going to use the line tool. I don't care. Perfect. So, if I take each of these as 1 inches, our gears are 7.5 inches across. So, seven. Let's go 5. Right there. And it goes 1, 2, 3 inches. That would be 6 plus the half of the center. 4, 8. Right there. That's what our circle looks like. So now, if that's 7.5 inches total, that means we need 3 8 by 8. Shit. We need 3 8 by 8 squares, essentially, with a single peg perfectly centered. So let's get on to that. Here's our model where we made our completed functional basic gears. We are going to need advanced gears. Do I do that now or do I wait? I'll do it now. So we need 90-degree bevel, circular hole. Let's get our measurement converter back. Okay. Again, Half an inch is 12.7 millimeters. We need a 12.7 millimeter hole. Okay? Module. This is teeth. This is half the size of our teeth. What did we go with over here? I don't recall. Because it's going to be this same size. Utilities measure. 0.8 inches. So it's 0.4 inches. Which is 10.1. I probably went 10 millimeters. 10 millimeters. Number of teeth. It's going to be coming off a big gear. I need one with 20 teeth, one with 10 teeth. 20 teeth. Pressure angle, I'll stick to 25. Pinion number of teeth, what does that mean? ChatGPT! ChatGPT! Help. What is a gear pinion? Okay, so this is a 2-pack of gears then. Here we go. So, it's coming off one with 20. We need one with 10 and one with... one with 20 to drive 2 with 10. 1 with 20 and 2 with 10. Hold on. Don't tell me I fucked this up again. No, this is the STL printer, so if I import that... oh, fuck. Where did you go to? What? Downloads. Oh, you're compressed. Let me extract all. Okay, here we go. So, that has 2 STL files in it. Okay, that gave us 2 90-degree beveled gears. Perfect. The small one doesn't have a hole in it, but I can fix that. That's fine. What I'm going to do, I'm going to move both of you over here. And what that's going to be bevel gears. Okay, now we know which those are. So theoretically, would okay. Theoretically, that could just provide power, but I would rather copy this. And then, instead of having you, I take this, move it over here, rotate, need to go 90 degrees that way. Okay, so instead I would rather do 45 to 45 transfer. So those teeth directly interact like that. And then you, that's an exact transfer. And then you are now no longer a crankshaft. You now you are no longer a connector gear. This becomes our crankshaft. So now this provides force straight like that, which will directly drive the crankshaft. So that is the very mechanical basics of the system. Let's go over to a new project. What do we got? Oh, I have some empty slots. Here we go. Here's one. Perfect. Let's start with this. Let me do some thinking here. Okay. If this is 7.5 and it needs to get to this, which is 3 inches, that's 10 inches between the two. That means this one needs to be bigger. This one needs to be smaller. And this one needs to be bigger. So theoretically, we would have like, let's just do some testing, shall we? Width. Let's go 8 inches. Height, 1 inch. Depth, 8 inches. Okay. Rotation, 0. Please, just default. Thank you. Done. So if I take this, this is now an 8x8 square. Forgot to go over here to this. And let's export you. Export as STL. You will be large gear in set, and save you to this location. Now that should be over here. No. That just went to documents, didn't it? Next, STL inset internal export. Next, let's get U export STL UR 90 degree bevel with hole. It can't have the slash in it. 90 degree bevel with hole. I need to export just this small one now. Export just the pinion. Choose format. STL 90 degree bevel no hole. So now I go back over here to downloads. I grab all of you, bring you over here. This is my asset folder for all of my CAD assets. All of my gears I've made, all of my gears I've downloaded are all right here. Okay, let's go over here to this. Shit. Cube. Perfect. 8 by 8. Done. Move. All the way down. Okay. Now an 8 by 8 cube, if I get copy, copy. If I get 3 of these next to each other, next, I import over here, large gear inset. Boink. And if I had you dead center, you would not do anything. So, you need, what, that much overlap? If I add now new project, import, inset, internal, that would be like centered. Okay. I need one more inset internal. Now, right there is where I need them. So, let's change the size of this plate. Which axis? In the blue axis. That will work. So if I change this one down to 5, relocate you in. Now select both of these, move you straight up. Okay. Right, next. Sphere. No, not a sphere. Not a sphere. cylinder. Color. First things first, it needs to be 0.5 and 0.5. Height needs to be 8 inches. Okay. Done. Color. Black, so I can see it. Actually, let's go red. Here we go. Perfect. Okay, next one. Needs to be like that. You need to be like that. Let's add another large gear with an inset. Line you up like that. Let's get our next cylinder in here. Just curious, that's 5, 10, 5, 10, 13 inches all the way across. Let's get another cylinder in here. 0.5, 0.5, and 8. Color. Let's get this red. Okay. Copy. Let's go ahead and get another gear and another internal in here. Right. There. Okay, let's get another cylinder in here. Perfect. That is a very basic, very primitive gear chain. And I'll show you the way we can improve this. I'll increase the Y size of this, drop it down, and now what was my plan for this? I wrote somewhere. Okay, here we go. Right, I recall. Let's undo, undo, undo. Okay. I need to go make a part real quick. Let's save this. Okay. I need this, and I need this. So pretty much, that's actually perfect. Wait, if I select both of these, stitch and scoop, subtract the inset preview. Yes, perfect, flawless, done. Now, export you as STL. You are 90-degree bevel with inset. Export. Now let me open downloads again. Move this over into my thing. And now I can go back over to train stand. And this big one needs to turn another inset internal. Which is going to drive a bevel gear with inset. Okay, and then from there, things get harder. What? What are you? Huh? Okay. Let me delete just this. What I have to do now is right there where that bevel is. Actually, I'm going to make this connection over here. So, what I need to do, everything from this model, I need to move over. You can have a couple degrees to the right. What I have to do to this model is make an extension and a subtraction. So I add another cube. Needs to be 2 inches by 2 inches by 1 inch. Done. Move it over here. Cancel. It needs to be 2 by 8 by 1 actually. Red. The size needs to be 8 in the red. Okay. Now, you and you need to merge. Combine, merge. Done. Now that's one solid bigger square that is not perfectly even. Oh, it's 1 pixel off. It's 1 pixel off. You can take them. I'm undoing that. It's a single pixel off. Red. Our red axis is wrong. 0. Huh? Right there. It's because there's a seam. What I'll do is instead extend this out from 5 to 7. And I'll just delete this one. Okay, now what I need to do is put a new square in here. It needs to be 6 wide, 1 tall, 1 deep. Seven. Now, if I take these two models, stitch and scoop, subtract this one, preview. Perfect. That's how you make a slot. Okay, now that slot is going to be what houses this gear is going to be over here. Right there. And then I'm going to get a 90-degree bevel with a hole in here. I need to move. I need to rotate you 90 degrees. Okay. Now I need to slot you there, and I need to drop your size down too. 6. 6. Perfect. Ooh, flawless. Except for all the flaws, but you know. Now, before we do that, we need to make one more subtraction from this, and that is a cylinder. 1/2 inch. What size? .7 inches. Okay. You need to be size 0.7 and 0.7. Now I need to rotate you 90 degrees. Nope. Nope. Perfect. Now move you. Let me just z-axis cut this down to like 3, so that's a little easier to work with. You are still centered. Is that correct? Perfectly centered. And it is 0.7 inches, which is fine. Okay, Let's select these two. Stitch and scoop. Subtract the cylinder. Preview. Yes. Perfect. Now I move this back up. Undo. Yes. Okay. And now to make another part, I need 90° with no hole. And now I need to go over here to crankshaft. This one's okay. 3D. Crankshaft. This one's pretty good. One, two, three, four. Yes, I like this one. This is actually exactly what I want. This one is free. These cost money. The shaft arm does not. I have to get a functional crankshaft, though. Wait a minute. No, I don't. Because it's going to be permanently attached to another object that's going to rotate. This is fine. This is perfect. Let me do this. Next, I come in here, back to my downloads. I extract this a long time ago. I just pop this in here. Does this work? Yes. Oh my god, yes. Perfect. Ooh. That's pristine. Let's scale it down. I can't have this be 20 inches long. It needs to be like 10. And I bring you over here. Rotate you 90 degrees this way. I move you over here. I now have to center this. And that there we go. Now we have a functional crankshaft. Okay. Next, here's where something gets a little fucky. I need cube parameters. 1, 0.5, 0.5, and 10. Done. Okay. 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 Now this is starting to look like something. Next, I need another cube. And this is still not even a product I can use. This is still just theory testing. Let's set you to 1, 10, no, 8, and 15. Hell yeah. Okay. Now here's the fun part. I could design this myself, or I can do some research. I think I might have to design my own pistons. Okay. It's 8 o'clock. Let's add some color into this. Okay. I actually appreciate the all gray thing we got going on. So, let's go make some parts. What are you, actually? just look around this website and see if we can't find anything. So this is the CAD Models website. A free CAD Models website. Right. Ooh! This is the exact thing I was looking for. Holy shit. This is the exact file, parts, everything I was looking for. Yes. Okay. 4-stroke piston. I want it for me. Let me make an account. Okay. Now I go over here. I confirm my email. Thank you. Sick. Refresh. Yes. Son of bitches, though. History. Four-stroke piston. U. Here we go. Can I download this now? Yes. Perfect. 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 Let me get this out of the way. I probably will not need this anymore. I was going to build it myself, but if I can get one that's already assembled, perfect. I can close all those tabs. I can come over here, downloads, extract all, okay. If I move this over here, this is the wrong one. Okay, it didn't work. Hold on a minute. This one. Cut. I'm going to make a new folder over here in my assets. This is going to be engine basics. Now I put all of this in here. Now, just curious, can I even use any of this without converting the file type over? Assembly 4-stroke piston, right? No. Hey! Scale. size. 3, 3, 3. Oh. Oh, all of you are different parts. Scale. Just generally down. Now, scale it up properly. Okay. Now we get this over here. Rotate it 180 degrees this way. And 90 degrees this way. Now let's put it up here where we need it. Okay. And then we have a functional 4-cylinder engine. Next, the fun part. Alright, get rid of this crankshaft. I have to make a housing for this. It's 8 o'clock. How long have we been going for? Not even an hour. Okay. Copy. Here's what I'll do. New. Cube. No. No. What is an octahedron?
Don't ask questions you don't want answers to.
But I think I want answers.
You don't trust me.
Let's design this over here.
Any Black Ops Zombies players will agree. We don't talk about the octahedron.
So I need to make
Forget the dodecagon.
I need to make this engine casing modular. Now how do I do that? For starters, I can port some holes in the sides and have some pins that run in here. And let's set up a closed face. Scale. Uh-oh, I turned my cube into a plane. Oops. I have effectively completely removed 2 axes from my cube. God damn it. Oh no, have I been muted this entire hour-long video? Well, we've made some very good progress on this. I now have a file of all of my parts. If I go over to CAD Assets, that's pretty good. I'm going to end this stream here because, oh my god, this is exhausting, but I'm having such a fun time with this. We'll see you guys next time. Bye-bye.